Hello everyone and welcome. My name is Americo Cunha. In this video, I'm going to show you how to use Insight Maker to build a powerful supply chain simulation from scratch. The core challenge in any supply chain is matching supply with demand. When these two forces are in balance, business is good. But when they become unbalanced, we get serious problems. If demand is higher than our supply, we get stockouts, which lead to lost sales and unhappy customers. If our supply is higher than demand, we get excess inventory, which wastes money and ties up capital. To understand this balance, we're going to build a simple shoe factory model. Our factory has a three-stage process. We receive component kits from a supplier. We assemble those kits into finished shoes, and then we sell those shoes to customers. The key question is, what happens if there's a problem? What if demand suddenly doubles? What if our supplier is slow? Where is the bottleneck? Today we will build a model to find out. All right, let's get started. First, let's build the visual structure of our model. We'll start by adding our stocks. Stocks represent the accumulations in our system, the things we can count. Our first stock is our inventory of raw materials. Let's name it component kit stock. Our second stock is our inventory of finished shoes. Let's name this one product stock. Next, we will add the flows. Flows are the pipes or conveyor belts that move material into and out of our stocks. This first flow represents our supply of new kits. Name it component kits per day. This flow is our assembly line. It turns components into products. Name it production per day. This final flow represents our sales to customers. Name it sales per day. The last part of our structure is the variables. Variables are the control knobs of our model. They hold the rules and assumptions that control our flows. Name the first variable component kits per day. Name the second variable production units per day. And name the third variable demand per day. Our structure is now complete. Now we will connect the pieces and define the logic. We use links to show that our variables control our flows. Next, let's set our starting conditions. We will start with a baseline scenario. Set the initial value of component kit stock to 100. Set the initial value of product stock to 0. Set the value of component kits per day to 100. Set the value of production units per day to 100. Set the value of demand per day to 100. This is the most important step. We will define the equations for our flows. For our supply, the equation is simply component kits per day. For production, we need to add our constraint. The equation is the minimum of production units per day, comma, component kit stock. This minimum function is critical. It means our factory can produce at its capacity, but it cannot produce more than the component kits it has available. For sales, we add a similar constraint. The equation is the minimum of product stock, comma, demand per day. This means we can only sell what we actually have in our product stock, even if customer demand is higher. Our model is now ready to simulate. Let's set up the simulation time. We will set the simulation length to 100 and the time units to days. Now, let's run our first scenario, the baseline. A graph appears. Let's interpret this graph. Both lines are flat. The component kit stock stays at 100. This is because the inflow from our supplier, 100 kits per day, is perfectly balanced by the outflow to production, which is 100 units per day. This is because the inflow from production, 100 units, is perfectly balanced by the outflow of sales, 100 units. The system is in perfect equilibrium, but it has no resilience. Now for scenario 2, the production bottleneck. Let's see what happens if our factory is slow. Let's change the production units per day variable to 50. Let's interpret this. We are only producing 50 shoes, so we can only sell 50, even though demand is 100. We are failing to meet demand. But now look at the component kit stock. It's rising. It's growing by 50 units every day. This is because our supplier is still sending 100 kits, but our slow factory can only use 50. This graph clearly shows an inventory buildup caused by a production bottleneck. Let's try scenario 3, the supply disruption. We will reset the production units per day variable back to 100. Now let's click the component kits per day variable and change its value to 75. Now we see the opposite problem. Our supplier isn't sending enough components to keep up. Because we only receive 75 kits, our production is forced to drop to 75, even though it has a capacity of 100. And we can only sell 75 units, again failing to meet demand. The bottleneck is now clearly with our supplier. Now let's try an advanced scenario. We will set the initial product stock to 50 and set the demand per day to 125. This is scenario 4, the overwhelmed system. Let's make sure component kits per day is 100 and production units per day is 100. Click Simulate. Let's analyze this. Our factory is producing 100 shoes, but customer demand is 125. We have a net loss of 25 shoes every day. Our small starting inventory is wiped out in just 2 days, and we are in a constant stockout. Our entire system, even at full capacity, cannot meet this high demand. Finally, Insight Maker has a powerful feature for what-if analysis. Click on the demand per day variable. In the Properties panel, toggle the switch for Show Value Slider. Do the same for production units per day and component kits per day. Now click Simulate. You can see the sliders on the right. You can now change these parameters live while the simulation is running and instantly see how the inventory graphs respond. This is the real power of simulation. This concludes our tutorial for the shoe factory model. You are now ready to build and analyze your own systems.